Others have joined, we hope. Just welcome, my name's Chris. I'm part of the AWS Aotearoa user group. So we'll just give people a few minutes to come on board as well. And so yeah, we'll just give us a couple of minutes. And just if somebody can in YouTube just post a little chat just to say just hello, just to make sure that in our streaming service we're seeing the YouTube chats, that would be appreciated, because last time we had a problem with that. Hey, hey Simon, hey Scott. Yeah, we can see the chats coming up. Thank you heaps, guys. Okay, cool. Okay, I'll wait to 4:32 and then I'll kick off. Thanks, Scott. I love your work too. Okay, so welcome to AWS Aotearoa user group. This is our November meetup. It's a virtual meetup, so no pizzas today, unfortunately. Nothing physical. But yeah, we've got a couple of speakers today. So what we're going to do is, in a few seconds, we'll just do a quick introduction between everybody who's speaking today. Then I'll give a quick update on how the user group is going. And then we'll get into our presentations, which will first be Todd and Dan from the BNZ. And then we'll have Simon from LINZ as well. Now, during the presentations, if you could put your questions into the YouTube chat, it would be great. And most likely, all the speakers will answer those questions at the end. We then have a quiz. This is the first time we've done a quiz, so hopefully it should go well. And we've got some prizes. We'll talk about that once we get there. And then we're going to do a wrap up. So we'll just start with quick intros. So as I said, my name is Chris. My name is Chris Watson. I'm the president of the user group. I've been involved in AWS for about 7 years and been involved in the user group for around 2 years now, trying to get us organized for meetups and all that sort of stuff as well. So I'm just going to introduce Todd. So Todd, if you could intro yourself, it'd be great.
Hello, everyone. I'm Todd Roseweir, and I'm the technical lead for the AWS Platform Squad within BNZ's larger cloud platforms team. My background consists of many years working in IT as senior systems engineer, pre-sales technical consultant, and solution architect, mainly for solution providers and supporting organizations in various sectors. Not long after joining BNZ, despite my background being predominantly Microsoft-based, I was luckily given the opportunity to join the AWS Platform Squad when it was first formed. At that time, I knew AWS existed and I could spell it, but that was pretty much the extent of my technical knowledge. That was about 4 years ago, and here I am now presenting to other AWS users, trying to give the impression that I know what I'm talking about. Thanks, Chris.
Okay, cool. And other person speaking with Todd is Dan. So over to you, Dan.
Sure, thanks, Chris. Hi, everyone. I'm Daniel Surendran. I am also a part of the BNZ AWS Platforms team, working with Todd. I don't believe what Todd said. he's pretty strong in what he does. Yeah, so I've been doing a lot of AWS stuff in the last 5 years, and I'm quite passionate about serverless and making sure we use serverless and managed services for the right reason. I'm also an AWS Community Builder, and in the past I've worked with RBNZ for eight years, doing a lot of public cloud initiatives and building the dashboard in a few AWS services. And I've worked through different roles, but my predominantly I've been a developer for the last 15 years. Yeah, that's me. Thanks, Chris.
Okay, thanks, Dan. And our last speaker who will be speaking, he's from Linz, and that is Simon. And I'll just bring Simon in now. Hey, Simon.
Hey, thanks, Chris. Hey, I have a very different background than Todd and Dan. I come from a spatial background, and AWS is more of a tool to enable working at scale for myself and enable new ways of working. So I'll be doing a brief presentation about how at Linz we are working in a more cutting edge or innovative way because of AWS.
Yeah, cool. Thanks, Simon. Okay, so I'm just going to give a very quick update on the user group. So exciting news for us. We're really running on the smell of an oily rag for the last few years. In terms of getting funding for stuff, we've been lucky to have had free venues, mainly at BNZ, but at a few other places in Wellington, which has obviously helped. And we've obviously had, when we have physical meetups in Wellington and Christchurch, we've tended to have AWS help out with refreshments and food and stuff like that. And we've got a sponsor that we've pretty much all organised. We've just got the final few things. We're just details we're working through. So it's going to come out soon. So that's given us the opportunity to use Restream and use Restream on a higher resolution, and it's going to give us some opportunities to spend some other money in ways that will help the community. Now we're working it through, and we should, touch wood, next week be able to announce who that sponsor is. So that's really exciting for us. And the other thing is that, as you may be aware, AWS every year has their reInvent, which is their big annual, used to be physical conference, now it's a virtual conference where they announce a whole bunch of interesting and exciting new features and products. And so what we're looking to do in December, about a week later, is both at Wellington and at Christchurch, we're looking to do a recap event, which is going to be a physical in-person event. What we want to do is we want to have people speak for around 5 minutes on something that's came out at reInvent, either a brand new product or some sort of new feature to an existing product that they think is interesting and would help what they're doing. So what we'd really like to do is not just is to have people come forward and say they want to speak about a topic. So if you're interested at doing this at Christchurch or Wellington, please email us at inquiries@awsug.nz and just say, hey, I'd like to speak. Now, obviously, you won't know what you're going to speak about until reInvent happens. So you will need to, in that week or so between, you'll need to obviously go through reInvent and figure out something you want to talk about as well. Good opportunity to get public speaking practice as well, and some kudos, and obviously help you learn a new feature as well. So yeah, that would be really, really good if you can be interested in doing that. And now over to our first set of speakers, of which that's Todd and Dan from the BNZ. Now they're going to speak about what was it? Completely forgot. Sorry, multi-account platform learnings and implementations as well. So I'm just going to hand it over to Todd. Todd, you should be online, and I'll just bring up your presentation as well.
Yep. Okay, hopefully everyone can hear and see the presentation. Now, before Dan and I say any more, we're obliged to include this disclaimer to protect the reputation of our employer for anything that we might say. Now I've got that out of the way, I'm going to be covering the first part of the BNZ presentation, and I'll then hand over to Dan, who will carry on with his topics and focus in on one particular feature within our platform that he pretty much developed himself. So you'll be able to see that he at least definitely does know what he's talking about. I apologize for this picture. This is Dan playing silly buggers, so we'll just move on. Now, of course, we're expecting to have an audience with quite varying levels of AWS experience and interests. We've tried to cover a reasonable range of topics in this presentation, so that hopefully all of you will find at least one topic that justifies you spending your time attending the session. For the same reasons, we've also kept the subject matter at a high level. Having said that, Dan will be going a bit deeper into one of his topics for those of you who are looking for something a little bit meatier. So the first topic we'll cover some of the cloud challenges at BNZ. This first one, speed and agility versus security compliance, is probably the biggest challenge we face. When everyone gets introduced to cloud computing, one of the first things they hear about is how the cloud makes it quick and easy to start consuming services. In the case of AWS, the range of available services is vast, and it's only getting bigger. AWS also teaches you very early on about the shared responsibility model, where they are responsible for security of the cloud, and we as users are responsible for security in the cloud. Now, since BNZ is a major financial institution, you'll be happy to know that we take security in the cloud very seriously. But as well as that, we're faced with very strict regulatory requirements from the Reserve Bank of New Zealand. And since we're also owned by the National Australia Bank, we also face regulatory requirements from them and the Australian counterpart to RBNZ, which is APRA. Now, when you're deploying infrastructure and applications in an on-premise environment, you obviously have total control over that environment, and there's a lot of default protection from external threats and misconfiguration. However, when your resources are located in the cloud using services that are managed by the cloud vendor, that's no longer the case, and a simple misconfiguration can expose your resources to the world. So while BNZ tries to allow its technology teams to play with pretty much any AWS service that those teams feel could help them meet their application development needs, we have to ensure that before any application goes into production with real data, that the services being used meet our security and compliance requirements. So this means that every service needs to go through a process called CSAM, which stands for Cloud Security Assurance Methodology. And that looks at what compliance frameworks the service has been certified against, for example, SOC 2, how the service actually works, what potential may exist for unauthorized access, data leakage, or any other concerns, and either deems that service unsuitable for use in its current state or approved for use, but subject to certain conditions. For example, we have a workload that's currently running in an AWS environment outside of the official BNZ AWS platform, which we're trying to migrate into it. And this workload uses AWS Elastic Beanstalk, which requires public subnets for some of the resources it creates. Unfortunately, public subnets aren't supported under the BNZ AWS platform architecture. So that means that Elastic Beanstalk can't be used for this workload, making the migration a lot more challenging. In fact, our GM for technology also sits on the boards of a few startup companies, and he's seen how quickly and easily those startups can deploy applications to the cloud, but he also recognizes that this just isn't possible within BNZ. And following on from that challenge is a similar one whereby technology folk who joined BNZ, having learnt or worked with AWS previously, find that many things that they try won't work due to the various security controls in place. And this makes the whole consumer experience for our platform less than ideal. Now, it's easy enough to produce a survival guide which documents everything they need to know. But the challenge is making sure that everyone who needs to read it knows that they should, and that they're informed when there's updates to it. And it's even worse when there's third-party vendors working in our AWS accounts. So all of this, these two challenges add up to a common situation where, although it might be easy for our technology teams to easily find AWS-based patterns for whatever they're wanting to achieve, that either AWS themselves or other organizations have developed, it's often the case that these patterns simply won't work in our platform as is. Another challenge that we face is that if you start implementing a workload in a particular cloud platform using a lot of native services, and where that workload will eventually contain large amounts of data, there's a certain degree of vendor lock-in. And if some weird situation was to occur whereby BNZ needed to pull that workload out of its current cloud location, that could be a very difficult and lengthy task. So BNZ has therefore stipulated that where possible, and certainly for critical workloads, these should be implemented as multi-cloud solutions. Now, depending upon the deployment tools you're using and the features offered by the chosen cloud platforms, this often means that it's not possible to use cloud native and or serverless technologies for those workloads, which, as most of you are probably aware, is the very thing that you're supposed to do if you want to maximize the benefits of cloud computing, reduce complexity, reduce admin overhead, and cost reduction. And finally, BNZ has quite a large number of staff working across the various infrastructure areas. And while application developers tend to adopt cloud computing concepts quite easily, that's not always the case in the infrastructure space, especially when you're dealing with hybrid and or multi-cloud environments for an extended period of time. In those cases, many infrastructure folk tend to treat resources such as EC2 instances as just another bunch of virtual machines to support, and tend to prefer using multi-platform aware tools to manage those resources. In other cases, infrastructure folk can feel that parts of their jobs are being outsourced by adopting cloud managed services. Now, as anyone who's actually worked with cloud computing within large enterprises can probably attest, this is definitely not the case. You may no longer be working with one set of technologies. However, you'll be working with another set that can be just as much fun. I know that in my case, it took me a long time and several iterations of thinking to fully transition from an on-premise mindset to a cloud mindset. And it'll take even longer to help colleagues of mine and other infrastructure teams make that same journey to arrive at the same destination that I'm already at. Now, if I've given the impression that BNZ is not a great place to work, that's definitely not my intent. These challenges actually make working at BNZ much more interesting as we get to come up with various solutions to address these challenges, one of which Dan will be showing you a bit later on. BNZ does provide plenty of support for learning and certification, and even opportunities to learn other cloud technologies if we wish to. The next topic I'll cover is AWS Landing Zone. Now, I'm not going to talk too much about exactly what this is. What I'll start off by saying is that our parent bank, National Australia Bank, had been using AWS for quite a few more years than we were. And when BNZ decided to embark seriously on the cloud journey, we had the opportunity to start with almost like a clean slate and the opportunity to use some of the newer technologies that weren't around when NAB first implemented their platform. So one of the decisions we made was to select AWS's Landing Zone solution to help us build that platform. Now, for those of you who haven't heard of it before, Landing Zone is not actually an AWS service. It's actually a solution that the AWS ProServe engineers help you implement. And as I say, it's intended to help you get your Landing Zone deployed in a multi-account fashion that follows a lot of best practices. Essentially, what it consists of is a code pipeline resource that controls the overall process. That then invokes a whole bunch of step function state machines, and those state machines use a whole bunch of lambdas to provision all your accounts and populate them with resources. It's pretty much all done at the end of the day with CloudFormation. It's just that that's the mechanism that AWS have provided for managing the complex CloudFormation environment. One of the other features that the Landing Zone provides is what's called the account vending machine. And this is simply a service catalog product that allows you to spin up new consumer accounts. And what that does is it creates the account and deploys a common baseline set of CloudFormation resources in there to do that initial configuration before you then hand the account over to the consumers to use. and that allows us to make sure the account is configured the way we'd like it to configured. As many of the compliance settings as possible are already baked in. There's VPCs created already for the consumers, so it just makes it that much easier for them to get going without having to do a whole bunch of initial setup themselves. And it is customizable. It's all handled through CloudFormation. So there's a bunch of CloudFormation stack sets that deploy the different parts of the baseline configuration, and there's a stack instance for each account in the organization. One of the features that we discovered when we were implementing Landing Zone was that AWS had used some Ginger to do a bit of tweaking, or allow for a bit of tweaking of the environment, which we found quite a neat idea. So as well as just having the straight CloudFormation, we actually have some Python scripts that add a little bit of complexity to the process, but make it a lot more flexible. So we actually have our test station and our production organization, and using these Python scripts, we can inject environment-specific settings into the CloudFormation templates, depending upon which organization we're deploying to. So everything we do is fully automated. So when we release or make changes to our test branch, that will trigger a deployment to our test environment. And likewise, when we then merge that change into our master branch, it'll deploy exactly the same change into our production environment. And using the Python scripts, we can have environmental specific settings that get injected into the templates to customize them for each environment. The other thing that we use the Ginger rendering for is to, as most of you know, with CloudFormation, you can pass parameters into your templates. But when you've got a large number of templates that share common parameter settings, managing all of those can be a bit of a nightmare. So we use Ginger to allow us to effectively have placeholders in all of our templates, and we can replace those variables just before the CloudFormation templates are generated and passed over to CloudFormation. The other thing we use Ginger for is to do a little bit more complicated stuff. Most of you who've worked with CloudFormation will know that templates can be quite lengthy, and there can be a lot of repetitive text inside them. You might be provisioning 20 resources, and each resource might have 30 lines of CloudFormation code in there, but each resource only differs by 1 or 2 properties. So what we do is we use the Ginger templating facility to allow us to just specify the portions of the resources that are different, and we get Ginger to automatically build the rest of the CloudFormation template for us. So it just makes our code base a lot tighter and easier to work with, and it makes it a little bit more manageable. We have had some challenges with the Landing Zone solution along the way. One of them is it hasn't been very easy to do phased deployments. So in our organization, we have accounts are grouped by the environment. We have non-production, pre-production, and production. If we're wanting to deploy a change, it hasn't been that easy to phase that change through those various environments. As far as Landing Zone is concerned, it's just a bunch of accounts, and when you update the CloudFormation stack, it's going to update all of the accounts accordingly. There are various ways that this has been addressed by consumers, and we've found a few ways of doing it, but it's certainly been one of the challenges with Landing Zone. The other issue we've had is the complexity of the customizations we've made has caused some performance issues and some scalability issues as our number of accounts has increased. And in some cases, that's been fixed by AWS making changes to how the Landing Zone works under the hood. Yeah, that's tripped us up a few times as well. Some of you may have heard of AWS Control Tower. This is actually the fully managed version of Landing Zone. So AWS are end-of-lifing the Landing Zone solution now that they have Control Tower. And this takes a lot of the headache and a lot of the challenges away. In the past, when we've looked at moving to Control Tower, it's been relatively new and there hasn't been an easy migration path from Landing Zone to Control Tower, and also the early versions of Control Tower are quite limited in terms of how much you could customize them. But as with everything over time, AWS have resolved all of those issues, and we're now in an engagement, or about to go into an engagement with ProServe to look at how we can migrate from Landing Zone to the new managed Control Tower solution, which will hopefully address some of these challenges, but still allow us to have the flexibility that we need. Another topic we just wanted to talk about briefly, and again build on the Landing Zone approach, was to talk about one of the particular projects that we undertook recently, which was quite a fundamental change to the underlying network architecture that our platform was using. Prior to implementing this project, all accounts were connected using the AWS Transit Gateway service, which effectively gives you a hub and spoke approach to make it easy to connect your consumer accounts together, as well as connect them back to on-premises environments through Direct Connect or VPN tunnels. One of the pieces of work we wanted to implement was the ability to have our own internet ingress and egress gateways rather than using the existing ones on-premise, and as well as moving to Direct Connect for connectivity back to on-premise. And those projects required that we separate non-production traffic and production traffic as much as possible. And the way that we did that was by migrating to a new version of Transit Gateway, which AWS had released, called Multidomain Transit Gateway. And that allowed us to segregate the traffic. Now, making this change was quite a fundamental change in the environment. And obviously we wanted to make sure that we didn't break anything along the way or cause any issues for our production workloads. And there were some other benefits that we took as part of this project as well. Prior to this, all consumers' accounts had their own VPC endpoints. This had the overhead where each endpoint was occupying an IP address in each of their subnets. So as the number of VPC endpoints you deployed increased, it started causing IP address exhaustion in their VPCs. And also there's cost to maintaining endpoints. So one of the other goals we had was to migrate to centralized endpoints, where we had a completely separate centralized VPC that maintained the endpoints, and we just shared those VPC endpoints out to all of the consumers. So there are a number of things we wanted to achieve with this project, and part of that was to build the new infrastructure using the multi-domain transit gateway, which sat beside the existing transit gateway, and setting up all the route tables and all of the centralized endpoint infrastructure and everything, having it all ready to go. And then we decided that the way we'd deploy it is we'd release it one feature at a time. So that the first feature that we would do would be to switch all of the consumer account VPCs from the existing transit gateway to the new multi-domain transit gateway, and not introduce any other features, just make sure that we got them in the new environment and that all the connectivity was maintained, but now the non-production and production traffic were going down separate tunnels as much as possible. And then the next feature would be to switch everyone over to centralized endpoints. The next release would be to then introduce the internet egress and internet ingress features. We also wanted to do a phased deployment. So we wanted to roll these changes out into all of the non-production accounts first. And then once we were happy that was working and consumers reported everything was fine, there were no issues, then do the same thing with pre-production, and then finally cut over to production. And the way that we were able to do that, again using Landing Zone, was that most of these changes that were occurring at the consumer end were within their VPCs, where part of the Landing Zone configuration was a VPC template that controlled their environment and deployed all the endpoints into it, and attach them to the transit gateway. And what we were able to do is, using part of the landing zone where it stores the OU that the account belongs to in the SSM parameter store, we were able to put some conditions into our CloudFormation template that we're able to check to see if the account is in this OU, then make these changes to the VPC template, otherwise leave it alone. And with that simple mechanism, when we did our landing zone release, the CloudFormation stack set went through, each stack instance checked to see which OU the account belonged to and made the relevant changes. And that allowed us to deploy that change right through all of non-production accounts. Then we did another update to the code template to tell it to make the change if the accounts were in the non-production or the pre-production OU. Again, run the release through, that then moved the next set of accounts over. And the same when it came to production. And by changing different parts of the template and utilizing the OU lookup for the account, we were able to roll each feature out one at a time and roll it out through each of the OUs. And we're quite proud of the fact that the migration went through completely seamlessly. There were no issues of outages reported by any consumer for any part of the migration that we did. So that was testament to the team and all of the effort they put into and all the testing and the way that they were able to find a way to tailor the transit gateway to do what we wanted. Another topic we thought we'd touch on is EC2 instance patching. This is something that could be of interest to you, and it just shows some of the thought processes that have gone into how we've done things at BNZ. Just by way of introduction, the way that patching had been done in the on-premise environment and the way that we went with the initial service offering for consumers was to simply connect them up to the on-premise patching mechanism. So for the Linux environments, the Red Hat environments, that was using the on-premise satellite servers, and for the Windows instances, that was using the on-premise SCCM, which is a Microsoft System Center Configuration Manager product, which patches Windows machines. So just by establishing connectivity and deploying the relevant agents onto the instances, we were able to offer that as a basic feature. The issue with the on-premise solution is it wasn't very flexible for consumers. There were some very rigid schedules for when patches went out. It was all centrally managed, and very little freedom or customization available for consumers. And it was a little bit of work to get it enrolled. The on-premise team have since replaced that with an Ansible-based solution and tried to make it more self-service. But again, the challenge for consumers is if they want to tailor the solution at all, then they have to learn Ansible and go in and modify some of the playbooks and associate their machines. And we decided this wasn't a very good customer experience and wasn't really a cloud-centric way of doing things. So we started looking at how we could use AWS's System Manager, in particular the Patch Manager feature, to offer another alternative which was possibly easy to use. And it turned out to be incredibly easy. All we had to do was create some patch baseline resources, which define what types of patches you want to deploy. Create some maintenance window resources that specify the different time windows that we wanted to do the patching in, and then some maintenance window tasks that just tie the patch baselines to the maintenance windows. And it was pretty much as simple as that. Again, using our landing zone solution, we were able to deploy these sets of resources into every account. And we even configured it in such a way that we had a Lambda function that we get triggered whenever it detected a new EC2 instance being created. And if upon inspecting that resource, we found that there was no patching policy that had been supplied by the consumers, we would automatically assign a tag which would enroll the instance into our patching solution. So literally from a consumer point of view, they no longer had to do anything when they deployed instances. They could just create instances. Those instances would be automatically enrolled in our patching solution, and according to the schedules that we'd pushed out, instances would be patched. And we actually had an occurrence where one of our consumers ended up placing a support call with AWS support one Monday because they detected that one of their instances had rebooted, and they were demanding to know what had happened and why it had occurred. And when AWS support looked into it, they found that it had been told to reboot after a patching run by our patch window. So that's how seamless and hands-off the solution was for consumers. They actually forgot that their instances were even being patched. And this is the cloud way of doing things. When you're using AWS managed services, you don't have to worry about whether the instances are patched. That's something that AWS just take care of behind the scenes for you. And we wanted to implement the same facility for our consumers to make their life a lot easier. So now, if a consumer wants to change the schedule for their instance, all they have to do is supply a different tag from the list of ones that we define, and they can change the day in which their machines are patched. Very simple. One of the issues we had with this was that the system was designed around in-place patching, which is really designed for your mutable instances, your long-lived instances. It doesn't work for instances which are controlled by auto-scaling groups or EMR clusters or anything like that. If you try and patch those machines and they need a reboot, what will happen is that you'll trigger the reboot. The ASG or the EMR cluster will detect that the instance has gone down, think it's bad, terminate it, and spin a replacement one up, which has not been patched. So what we had to do was, in our patching solution, when we're scanning for a list of instances to patch, we checked whether they've been launched by an ASG or an EMR cluster, and if they have, we currently leave them alone. One of the enhancements that we're looking at making is to now effectively patch these machines. And the way that we're doing that specifically for ASGs in the first instance is that a number of things that we're doing. The first thing we do is we allow consumers to tag their ASGs to specify whether they want the managed instances to be effectively patched or not. If they don't set that tag, then we leave it alone. But if they do set that tag, then we'll look at patching it. The other thing we do is check to make sure that they're using one of the base AMIs that we support. And if they are, what the process does is it modifies the launch template that the ASG is using to say, hey, there's a new version of the AMI which is fully patched that you should be using instead. And then it just performs a rolling termination of the ASG instances according to our standard schedules. So what that means is that we have the ability to terminate the ASGs one AZ at a time, because we have different maintenance windows for each AZ. And that allows us to phase the replacement of the instances with newly patched ones. It still gives the consumer the opportunity to make sure that everything's okay before we touch production. Once we go into production, we're still terminating the instances over a period of a few days. So again, it gives them an opportunity if something was to go wrong or they detect an issue that's associated with patching that they weren't able to pick up in their testing, they have the ability to stop the progression from going any further, switch back to the previous version of their launch template and replace their instances again. So this is just another example of how we're trying to make life simple for our consumers and take away the need for them to have to worry about their instances being patched. Another feature that we were wanting to introduce was the ability to support the ability to run tasks before and after patching. Sometimes you have situations where services don't shut down cleanly, and if you reboot an instance, it doesn't come up cleanly, or you get some services that don't auto start properly. So having the ability for people to gracefully close things down before the instances are rebooted and again bring things up again afterwards was something that we were toying with how to implement. And fortunately, Amazon, like they do with a lot of things, added that feature directly into Patch Manager. So now there's support for pre and post patching tasks. So our next stage is to implement that feature and tie it into tags. So the idea is that if a consumer wants a pre or post task to be run, they just create the corresponding tag, and then the tag value will have the location of the process they want to run. And then our maintenance window will check to see if that tag exists, and if there are any pre or post patching processes to be run, it'll invoke those before it then kicks off the patching. So again, the whole process is to give the consumers the ability to tailor the patching process by simply having to specify tag values. Nice and simple. And the other feature that we're looking at implementing is more advanced scheduling. At the moment, we publish some standard patch windows, which for most people are working fine, but we do have situations where consumers need instances to be restarted in a particular order, or have some unusual uptime windows they need to meet. So again, the idea is to give them the ability to have their own custom schedules simply by setting tag values. Another feature we're using of AWS is the Instance Scheduler, which is a feature that allows you to schedule windows during which servers should be powered up or powered off, and it's provided as a cost-saving mechanism. So you can have all of your instances shut down outside business hours or shut down on weekends, and automatically start up again ready for business the next day, and save yourself some money along the way. So we're looking at taking that same facility, which uses tag values to specify the uptime and the on and off times, to roll that into our patching solution to again allow people to specify the order in which they want servers to be patched, or customize the windows just by setting some tags. The next topic we just wanted to talk about is, we touched on it before in the challenges, is about changing people's mindsets. One of the common approaches that I mentioned before is that people who are struggling to understand the cloud tend to adopt this multi-cloud toolset approach, where they believe that the best solution is to use, and in some cases even purchase, a third-party tool which has the ability to manage resources in multiple cloud environments. And sometimes they think that's learning the cloud. And as far as I'm concerned, that's hiding behind a tool. That's not actually learning the cloud. The other option you've obviously got is the cloud native approach, which is where you use the services which the vendors provide you, and in many cases they're free, or if they're not free, they're extremely low cost, and they're much simpler to manage. And it's the main challenge you have is striking the right balance. Some teams will argue that they don't want to learn two different ways of doing things. I would counter that argument by saying that yes, you might have to learn two different ways of doing something, but you only have to learn how to do it at an operational level. Adopting a multi-cloud tool set means that you might only be learning one technology, but you've got to learn it to a much deeper level. You've got to know how to install it, configure it, administer it, maintain it, make sure it's backed up, make sure you're doing DR tests. So at the end of the day, you're probably having to learn a lot more than if you just learnt two or maybe even three cloud native approaches. The other thing you're doing is by learning the cloud native approach, you're actually learning the cloud, not hiding behind a tool. So it's giving you an opportunity to really get your hands dirty and see how the cloud works and start using cloud tools. Now, there's a couple of examples I can briefly talk about to illustrate the type of thing I'm talking about. One of those is when you come to patching. I've already mentioned we've got our patching tool. Now, one of the objections that could be raised to this approach is someone could say, well, how do I know as a manager that all of my instances are fully patched? If this team's using tool A and you're using tool B, I've got to look in two different places to know whether my resources are compliant. That can be quite easily be addressed, and National Australia Bank had a tool for doing just this, which they called Cloud Compliance Aggregator. And it was a very, very simple tool to get up and running. and demonstrates how by adopting a different mindset, you can actually still achieve what you need to achieve, but at the end of the day, do it a simpler and more cost-effective way. And all this tool consisted of was a bunch of scripts, each one of which would go into a particular tool, and using the either the API that was available or a simple database query, was able to get a list of all of the instances managed by that tool and whether those instances were fully patched or not, and just spit out a simple file. So you could actually go to each of the teams who are responsible for each of those tools and get them to write this very simple script that just pulled that knowledge out, dumped it into a file. There was another script that just picked all those files up, merged them together, and threw them into a database. And then finally, there was a very simple website that just pulled the information out of the database and displayed it. So just with a handful of very simple scripts, you can effectively provide that single pane of glass. And once you've implemented it, there's very little to maintain, apart from version upgrades for the programming language you're using for the scripts, and possibly the occasional change when a particular patching tool vendor made a change to their product. Very little maintenance, no licensing costs at all. And if one team decided to switch out tool A for tool C, again, all they had to do was just modify the script to pull the information out, dump it into the same file, everything else carried on working. Another example of challenging people to think a different way is with the creation of operating system images. Currently at BNZ, we use Packer, which is driven by a Jenkins pipeline, to create the various AMIs that we use in our environment. And this is quite a useful tool to do this, but it does require that you've got Jenkins and Packer expertise. Now, there's another team within BNZ who effectively manages the server fleet and the configuration of them, and they're wanting to take over this process and extend it to support both on-prem and the Azure Cloud platform. And their mindset is, well, we need to have this tool that's multi-platform, and we need to control this process and leverage this to build all of your images for you. And that becomes quite complicated, and still has this requirement to support these technologies. The other way of thinking about it is for this team not to own the process, but just to own the content. So, for example, the important thing that they need to contribute, which is something that we would love to offload as an AWS platform team, because it's not our core expertise, is the installation of the various tool sets that have to go onto every standard machine, all the security monitoring tools and antivirus tools, that type of thing, all of the hardening scripts that have to be run to make sure that the instances are secure when they're first deployed. We'd love to offload all of that to a team like the server fleet team, who has all the expertise and can take care of that for us. But what we would like to do is have the flexibility to let them own that content, but to allow us to, for example, use Amazon's EC2 Image Builder to actually build the AMIs. That has the benefits of still having the server fleet team managing the part that they have the expertise in, but rather than thinking that they have to own the process and introducing all this extra technology, you can leverage the cloud native services that the various platforms provide, and simply just control the content. They would control the installation files that are stored in the repo. They would control the scripts that perform that installation, but we would use EC2 Image Builder to actually pick up those scripts and pull that content in and control the AMI process. And likewise, the Azure guys might have another equivalent tool that allows them to pull that same content. That way, the server fleet team can just concentrate on the content that they understand. And then when they're ready to come and take the cloud journey and are happy to learn things like EC2 Image Builder and the Azure tool, then we can work with them to show them how it works, and eventually they could take over the running of those resources, but they're also coming into the cloud and following us on the cloud journey. The last topic I'll cover before I hand over to Dan is some of the approaches that you can take to making sure that you create compliant resources. And this follows on from some of the challenges I mentioned about being compliant by default at the bank and making sure that resources are configured appropriately. So there's a few ways that you can do this. One of them is you can provide code snippets for your consumers to say, here's a piece of code that builds a particular resource with all of the controls and properties that it needs to be compliant. Just use this in all of your infrastructure as code templates. One of the issues with doing that is that you've got to decide, okay, well, which infrastructure as code languages are we going to support? Are we going to release CloudFormation snippets? Are we going to release CDK constructs? Are we going to release Terraform templates, all three, or even more? Another option that we've adopted in some cases to have behind the scenes Lambda functions that detect resources being created, check to see if they've been configured properly, and if they haven't, step in and make those changes automatically for the consumer. So the consumers don't have to worry. If they don't realize there's various controls or properties that need to be set, it doesn't matter. We take care of it for them. They can carry on with their job. There are some challenges to that as well, and that is that sometimes you can get into a conflict between who's managing a particular property, and we've had instances of that ourselves where we've detected, for example, an S3 bucket being created. There's no endpoint policy on it, so we go and put the default endpoint policy in, and there can be some timing issues with infrastructure as code. And what was happening was that we'd see the bucket being created, no policy on it, so we'd go to write a policy. In the meantime, the consumer's infrastructure had created the bucket and was just about to write the policy, but then our Lambda came in afterwards and overwrote it. We've also had instances where if we start modifying properties on resources, it can stop CloudFormation from rolling those resources back if there's an issue, because there's changes that have been made that it's not aware of, and it prevents it from doing rollbacks. So although that might seem like a nice approach, there are some caveats around using it. So the other solution that we're trying to move more towards is the use of AWS Service Catalog. And the idea here is that we will create products that will create the resources on behalf of the consumer and put all the appropriate controls in. And if consumers need to tailor it in any way, then we can provide parameters as part of the launching the Service Catalog product that allow the consumers to make any custom changes that they want, and then we'll take care of doing everything for them. And the good thing with Service Catalog is that it can also be fully automated. So if they're using infrastructure as code, all it means is instead of getting their infrastructure as code to deploy a resource directly, they get their infrastructure as code to request a Service Catalog product and still supply all the same properties they would like it supplied, and we'll take care of it for them. The other advantage of using that approach is that if some of those security controls change over time, we can handle that for the consumers. We can automatically release a new version of that product that implements those additional controls, and even automatically update their products to that latest version, so they no longer have to worry about keeping their resources or their infrastructure as code up to date. So having reached this point, I'll hand over to Dan, and we'll continue this discussion around how we're using service catalog products. Thanks, Dan.
Chris, I think you should share my screen if you can. You're still sharing Todd's.
Sorry, guys. No, sorry.
Perfect. No, not yet.
Is that it? Daniel Surendran AWS Platform? No, that's not. Sorry, wrong one. My bad.
Cool. Yeah, that's the one.
There we go.
Cool. Thank you. Thanks, Todd. That was pretty comprehensive. Sorry if I'm moving a bit. I'm just standing in the kitchen So that's my day. Today has been a lot of packing, moving, cleaning for me. So while we ease into the next session, I just thought I'll just show my kids up there, and they're there, Ephron and Edgar. I said I'm going on live stream, and they said, can I be on it? And they're not next to me now, so I'm just putting them there on the pic. And that's my grandmother. She is 102. She is watching the stream. So hi, Amaji. Let's just get into it. Cool. So as Todd mentioned, we are quite big in self-service catalog products in BNZ. And a couple of years back when I joined, we had a few products, and slowly we started building as a team quite a few self-service products for our consumers. And we believe that's the only way we could scale. Just a list of products that consumers or account owners can launch are these. We've got a compliant S3 product. So a lot of S3 buckets can be created, but if you want to be as a compliant S3 bucket, you would want to launch it through our self-service catalog, which is the service catalog that we use. We've got a slight iteration of that same product into the list, which is this S3 Spa product. Where if someone wants to create an S3 SPA application and want to upload their content into and make sure that it becomes quite functional quite immediately without having to worry about any sort of a security implication. We've got compliant EC2, and we kind of have this and make sure when consumers launch instances, they could launch Linux or Windows, but it still is compliant, and they don't really have to do anything hugely different. So if you're trying to do this through your console or through CLI or Portal 3, you've got to follow through a list of manual steps, and all of that is cut short by launching through Portal. And we've got a product that specifically caters for a KMS key. So if a consumer wants a key for, say, CloudWatch Logs or S3 or RDS, they could go into the portal and say, I want a KMS key for this, and this is the service I would like to use. And that basically creates a KMS key for them, completely automated at the back, and gives them the ARN of the KMS key. Similarly, IAM user, we've got compliant Nexus stores that you could create through the self-service, and compliant EMR cluster. There's an asterisk there because the best part here is the faster you could create and you can deploy, it's the same speed you could basically get something deprecated. So it gives you that agility when you're launching self-service products through service catalogs. So currently our EMR cluster is in the backlog. We've got, this is a big piece of work, which is the ingress and egress connectivity, making sure the consumers can access the public internet, or they can access the other way coming in securely. There's obviously other rules and firewalls that needs to be set, but this enables them so that the VPC can talk to both ways. We engage with ProServe, which is a separate wing of AWS they come down and they basically build stuff and help us deploy. And we had to do a bit of iteration after that, but yeah, that's what ProServe does for us, which is pretty cool. It kind of acted like a spring pad for us to do something really fast. We've got a cloud native CI/CD product. So when someone launches a CI/CD product through a catalog, it gives them a code pipeline, which is secure, which is compliant, and we are still working through that currently. So it's work in progress. Compliant Bastion, compliant load balancer, and a break glass. This is pretty interesting. So if the consumer would like to go ahead and fix stuff in production, and they want like a quick access to it, they basically launch this product, get access for a specific period of time, and they get to do what they want. And this is all completely audited. So it kind of helps us to give them that feature without having to go through multiple loops. And the next one is pretty much what we're going to talk about in detail a bit, which is the AMI transporter. And we want to build something that enables consumers to move AMIs from one account to another account. And that's probably easier, but if you want to do it securely and following our standards, it gets a bit slightly complicated, and we'll probably step into it a bit in detail. The only thing I can't do right now is I can't do a demo or show anything on the console for security reasons. But we will try to give as much as information as possible in terms of the implementations, the building blocks, and what sort of learnings we had when we did this. So we'll be talking about implementations and the learnings. Just a bit of a agenda, really. We'll talk about the background of where this has come from, and what are we trying to solve, and what are the building blocks that we used within AWS services, and also go on a little bit on those services to kind of talk to you about how each of those services are used in an AMI transporter sort of a use case, and what could be used, and if you're doing something similar, or if you're using a similar service in AWS in this fashion. We also kind of quickly touch into the architecture of it and look at some sort of a flow of how this works, and also kind of share you some of our learnings after that. So what's the story? So we're talking about AMIs here. So AMI is Amazon Machine Image, as most of you would know. And the way it works at big enterprises is there is a specific team who builds these AMIs, which is us, which is so me, Todd, and our wider team. And once we build this AMI, we basically let the consumers use it. So we share it with the consumers. So once that's done, the consumers, they would like to create an AMI off the base AMI. So SOE stands for Standard Operating Images, Standard Operating Environment. So once they are clear on which AMI, whether it may be Linux, or whether it could be RHEL 7 or RHEL 8, or whether you want to use it for EMR, there's a whole raft of AMIs that we create, and we share it to the consumers, and the consumers pick it up and say, oh, okay, so I want to use this for my application. Because my application runs on a VM. So I want to create an EC2 instance. So let me create an EC2 instance, and I want to use the base AMI from the golden AMI from platforms, which has all the stuff which we'll talk about in a minute. And they put their stuff on top of it, which is the consumer build AMIs. So once they build it, they could use it in their account. But what happens if they want to use it in a different account? If they want to use it in pre-prod, like what Todd was talking about, our OUs are split quite discreetly for different compliant reasons, like non-prod, pre-prod, and prod. And there is a definitive reason why we do that. And especially when you're moving stuff between these environments, we've got to be really careful. There are security implications onto it. So we want to give them something that we were basically looking for, something that helps their life, makes their life a bit easier. And that's the sort of a background. But if you look at in depth on what we do in the first step, we basically add security tools and extra frameworks into this base SOE AMIs. And you can think about like McAfee, CloudStrike, all of those security tools. There's quite a lot to it. I can't talk in depth about it, but I'm happy to have a chat if you're looking for a specific vulnerability check, or if a specific reason on why you want to add this specific tool or not. So once we bake those AMIs, we make sure that it is restricted. So what we try to do is make sure that we've got like 150 accounts really. So we make sure each of those accounts, they use only the AMIs that have been created by the bank or by our team, to make sure that it's consistent, point one, and it's secure, point two. And for that, it has to be centralized. So we've got a centralized place where we build this. Like Todd was talking about, we use Packer, Ansible, and to basically build it. And we are looking at exploring image builder in the future. So once the golden image is created, what consumers do normally is, if they are building an application on a VM, they basically install or bootstrap stuff into their AMI basically. So anything application specific, could be config files, could be the application installers, or any sort of application component they would like to install. They make sure they bake it in, which means that they use the base AMI and they bake in their stuff, and then pretty much that's the AMI that they would want to use. The main reason they want to use this is because they want to, a lot of the consumers do use clusters, say auto-scaling group, EMR clusters. So when, as you probably know, when you're dealing with clusters, you want those instances to be up and warm pretty fast. So in order to make sure that the instances get into auto-scaling group fast, you would pretty much want to rely on a pre-baked AMI instead of bootstrapping it every time an instance joins a launch configuration, or sorry, an auto-scaling group. And the way that we've seen our consumers do it is they've got this really smart baking pipelines that they build using Jenkins or any other CI tool. And they put in their application components and they make sure they build it up. And what they would want to do is build it in one place and use that in different other accounts. They can basically share between prepared accounts, which they own, or they could also try to share between a different business unit who owns a different account altogether. That's the problem that we're trying to solve. So if someone wants to share this, how can we automate it? Do they really want to share it, or does share really work? And do we need to copy the AMIs? What's the difference between share and copy? And those are the questions that we had to ask when we started looking at this particular feature. So the main important thing here is to make sure we can keep them, keep the AMIs or keep the whole process secure and compliant. And how can we do that? So now, before we step into the architecture, we always try to simplify things. May it be service catalog, may it be the multi-domain transit gateway. We try to simplify a lot of those things. So we had to think about at least 2 or 3 ways of simplifying what they're trying to do. So when we looked at our consumers, they were trying to bake their own AMIs, and currently, like before we had this feature, there was no easy way to share or copy. There are a few reasons for it, because they need to worry about security, they need to worry about which account they can share it to, and a few other compliant reasons for it. So that's one main criteria that we had to take account into. And also making sure it's such a complex mechanism when you're dealing with enterprises. So mainly because of the security aspect of it, and also making sure that there is no delay to be able to run these AMIs across different environments, because they want to quickly jump from non-prod to pre-prod and to productionize, so and to prod. So we want to make sure that transition is a bit easier. And this is an existing process, so there is a manual way of doing this. And main point here is the manual way is time consuming and it is complex. And we also observed that the consumers, or people who are building these AMIs, the application specific AMIs, they have to build redundant infrastructure in every single account to build these AMIs. So can we basically reduce that? So these are some of the concepts that we were looking at when we started to look at what we are trying to simplify. So next is around what we do need to automate. So we know that we need to automate something for the consumers to make their life easier, but what are we trying to automate? So if I just jot down the list of steps, there is key policies you got to deal with, because it's backed by ABS. The AMIs are backed by a block store. So, and the block store has to be encrypted in huge enterprises. And one way to keep them secure is to have a key policy on and make sure that the way you share your key policy is pretty tight. And then you've got to make sure you share the AMI. Again, there are some parts of these steps are done by the consumers and some has to be done by platforms team, which means there's a bit of a coordination that needs to line up. Not only the AMI sharing is needed, you also need to share the snapshot behind an AMI, which is the ABS. And we need to make sure we give the proper key grants to an IAM role. And this has to be done with the consumers. And this is typically use case if you're using auto-scaling group. And grants are pretty tricky, but we'll talk about it in the next few slides. We need to make sure the target account, which is where you've got a source and you've got a target, you want to copy an AMI from here to here. You want to make sure that the target account also has the right grants to consume, and make sure you can either share or copy so that you can launch instances based on that AMI. We also have to adhere to a zero trust policy, which is do not trust anybody immediately. So even if you do, you make sure you give them temporary access. So to complying to that, we need to make sure that once the job is done, take all the permission that was given. So that's a key requirement for us here. So that needs to be done again by the consumers, coordinating with the platforms team. The one way to do it is, again, the key policy update. The other key kind of a requirement is to make sure that the sharing between AMIs, or sharing between accounts on AMIs, only happen on one direction. So you could build an AMI in a non-prod environment, say an account A, but you can only share it to account B. So you need to have some strict rules around where these AMIs can be shared. So looking at all of these, we were looking at a couple of options, really, whether we copy it or we share it. But then whatever we want to do, we still want to build it within AWS. Obviously, we're AWS Platforms team. So you looked at different ways of doing it, and so some of the building blocks, so some of the components that we use within AWS. So again, the intention here is there are lots of different ways you could do it. But in case if you're using one of those services, which we're going to talk about, may be step functions. We've used step functions to orchestrate the whole states between how the AMI gets copied securely. We used Event Bridge to move data from an account to another account. Pretty simple, really. Service catalog. This has been our primary product that we use to provision or help consumers use or provision self-service products, and I'm a big fan of it. It makes things a lot easier for us and the consumers. But again, there are a few teething problems which we constantly try to solve. But the main good thing about Service Catalog is it gives you the agility around which project you can launch, who can launch, how they launch, and if you want to deprecate a product, you could do that. So it gives you a lot of control, and you can build things that are compliant. The other main, obviously, without IAM, nothing works in AWS. So we definitely use IAM for the roles. So KMS plays a key part here, mainly because all our AMIs have to be encrypted, and we've got an ABS for snapshot behind it. And when you're dealing with AMIs that are encrypted, you need to deal with KMS keys. There's no way around it. And even whether you share it, whether you copy it, you need to make sure the KMS keys and the policies are set the right way. So those are our building blocks right there. And with those building blocks, we did a couple of iterations. The good part about AWS services is pretty much a lot of people say this. It's like Lego. So you've got a lot of blocks, and you've got a business problem. So fit all together in a right fashion that works for your business unit or works for your application, and you come up with really cool, workable, secure design that can be productionized in less than a month's time. So from, say, development to production, things are really fast, and I keep re-emphasizing that because for me that's like one of the key benefit, and when you're using those building blocks within the same cloud provider. So they're looking at the architecture. So I'm just going to see if I can actually create a laser pointer just to point out, so it'll be easier. So we've got there are a few boxes out there. So we've got a consumer account, which is a source account. And we've got a consumer A account, which is, say, if it's a destination account. And we've got a KMS account, which is where we store our KMS keys and pretty securely. And we've got master account like you would have when you're dealing with multi-account. So that's where all the accounts are stored and managed through organizations. And we've got this shared services account. You could call it like a central account where we do common stuff. So the way this thing works is like any other service catalog product. So we use service catalog. So that's service catalog for you. And what happens here is when someone launches service catalog, you could do whatever you want because it's CloudFormation at the back. But for this particular feature, what we do is when we launch a service catalog, we basically initiate an event that gets passed into an event bridge that sits in a central place, and that's this. And the event basically has all the information about what needs to be done. And if you look at the request is pretty simple. The request would have what is the AMI you're trying to copy and to where you're trying to copy. So no other. So we try to keep the information we require from our consumer really simple. So the more options you have, it's going to be really hard for the consumers to use. And we did a few iterations. I should thank the other business teams who helped us test this, which is quite cool. So it's good to be able to test as you develop. And so here, once the event gets passed into the event bridge, so what happens is we've got an event rule that's set, and it looks for this particular event, and it basically initiates. You can initiate the step functions in 6 different ways. I'm just saying it because there's a quiz coming. So when the event gets through into the common account, it initiates the step functions. Pretty simple. And we've got the step functions defined. So we'll talk about when we deal with step functions, what are the things that you need to be careful about. But step function ideally is a state machine which lets you go through different states and do what you want. There's lots of really cool features. It supports more than 200 plus services that's tightly integrated to step functions. We use Lambda. We use some inbuilt states here, like this wait and choice state and pass, fail, success, and these are all the custom lambdas that does its own thing. So step functions are really powerful tools for orchestration if you're trying to do any sort of automation. So once the event comes through, it initiates the step functions. The step function goes through one step at a time. I think I might have a slide to talk about each of those steps, but on a high level, when the event comes through, we basically do a lot of checks to validate the request. And we've got 2 levels of validations. We've got validations at the source to make sure that whatever the consumer or the user enters in is valid. And once it comes into the step functions, we again validate. We gather all the initial variables and make sure it's ready for the next steps to process. So we do things step by step as you would do manually. So you would basically look at sharing and EMI. You make sure the KMS key policy is updated in the right form. And once the sharing of the EMI is done, you basically share the snapshot. Make sure you look at which ABS it's using and look at the KMS key the ABS is encrypted with, and go and look for the policy of that KMS key, and then upgrade that to something that would let this copy happen. So once all set, we do a copy. So the key part about copy is async process. Inherently, it's async, so it's really hard. Say if you're launching and if you want to copy an EMU that's 100 GB, it's going to take a long time. And how do we make things synchronous? How do we let consumers know that you can wait for it? And nothing breaks in between. So we've got some process set for that, and I'll talk to you about this process in a minute. But once the copy is done, it basically looks at whether it's copied or not. So it looks for an EMI that it tried to copy, and looks at whether this particular EMI is copied or not for every few seconds, and it runs in a poll fashion. So it waits for a limited period of time, and it checks again. So similar to if you're dealing with creating VPNs, or if you're creating VPC attachments, things take time. So a lot of AWS resources take time, and when you're dealing with resources that take time, and when you're dealing that inside an orchestration engine like step function, it makes it really easy, because you can actually wait for the state to be complete, or a green state, rather than something that broke or something impending. So once the copy is complete, say if it takes 20 minutes, once the copy is complete, then it basically sends the message back as in a different form. It basically updates the SSM parameter, and the Lambda inside every single account basically looks at this parameter to make sure that there is a recent update from when you initiated this request. So the interesting thing about these things are we've got an existing infrastructure that's built to create KMS keys. It's completely decoupled, so you could use a request and you can send an item in a queue, and that item gets picked up and thus create a key or update a key, and it comes back with saying, oh, I've done your job, here you go. And we do that as a part of the step function as well. So that's a sort of a high level architecture, but we'll kind of go into those components slightly in depth. But before we do that, when we tried to do this and when we tried to do a pilot, we were looking at how are people launching these. We know how people launch users, for example, creating an IAM user through self-service portal. But how would someone launch an AMI transporter? There are three different ways we found consumers launch this. The first one is obviously through the management console. You go in and you basically go into the service catalog portal and you click on this product and you say launch, give the parameters and launch. The other way a lot of consumers have started doing is using Terraform or CloudFormation. This is a good thing to know, which is you can launch service catalog items through Terraform and CloudFormation. And the way you do it is in Terraform is using service catalog provision product resource, and for CloudFormation it's this resource. So it really works, and it's quite easy for you for any consumer if they're trying to build an IAC platform and they want to integrate a compliant resource made by an enterprise platforms team, then they could still use a resource when they're building and they go to CloudFormation. So if they're building an S3 bucket, they don't really have to say, I'm building an S3 bucket, so give me an S3 resource as you would. Instead of doing that, you can actually provision an S3 bucket that's BNZ compliant. So that's one way that a lot of our consumers use it, because a lot of our consumers would like to deploy stuff in production through code. And the other way is CI/CD. Again, CI/CD and IAC work hand in hand, but you can also see some consumers trying to create or launch these products through Jenkins pipeline using CLI. So those are three main ways people use it. So I keep saying portfolio, product, and service catalog. So what are the interesting things that we found when we created a portfolio product for a scenario like an AMI transporter? So AMI transporter inherently is an async process. It's going to take a long time. So how can we make it a bit synchronous or completely synchronous to make sure it comes back with a response and let the consumer know that, okay, it's 20 minutes. You got to wait for, and this is going to be complete. And once it's complete, this is your new AMI ID. This is where it's copied. And if it doesn't, we'll let them know that it hasn't copied. It's failed at some stage. And the way we do it, this is a pretty cool feature. It's a feature of not really CloudFormation, but if you're using custom resources that are backed by a Lambda in CloudFormation, you could use something called the poll create. So if you're using a CFN resource helper, you could decorate it with poll create. What poll create does is it basically looks and it creates an event at the back and helps you run a Lambda in a loop. So, Lambda is a limited timeout. So if Lambda has a 15-minute timeout, if you want something, if you're looking at using the Lambda for something that runs beyond 15 minutes, say for like a couple of hours, and if you still want to use a custom resource that's backed by Lambda, you could still do it. The way you do it is through using poll create. So at the start of someone who launches, we have a few validations. And these are the validations. I wouldn't go too much in detail because this might be different for each consumer. So we use AWS KMS service, which is a key management service that helps you create keys. The two types of keys, symmetric, asymmetric. This one of the key service that I think everyone should be using, and I hope will be using. So when we use KMS for this particular scenario, I would like to point a few things. So KMS key policy. the significance of KMS key policy is the key, because without a key policy, a key is basically nothing. So and just a bit of a understanding here is key policy mainly has three parts to it. And one is a key policy that enables the root user to do stuff on it. Basically, the main logic being root user cannot be deleted, so you want at least one person to be able to hold on to the key or access a key. In case all the other IAM entities don't have access, you still have root access. That basically makes sure you don't lose your key, which gets you locked out. And the other two parts is quite interesting. So the key use policy, which is who can use this key, which IAM user can use this key, or which IAM role can use this key, and which account can use this key. So that's the key use. Persistent resource is the third part. So again, key policy can be structured lots of different ways, but there are three main parts. The persistent resource is more like when you have an AWS service like auto-scaling, trying to use a key, you want to make sure that that service, though it's not a part of your account, that can still use it. So to make sure that that works, you want to have that in place as well. So apart from that, there's lots of other restrictions you want to think about, which is basically when you're sharing between accounts, you want to make sure the only way to share is using KMS policy. You can't really go and click on the console saying, I want to share this KMS key. You will have to use key policies. You want to make sure that how we distribute those key policies was quite key for us in this particular use case. I would spend some time thinking about the controls. There's quite a few conditions that you can use and you cannot use inside a key policy. And like things like make sure that it can only be accessed by an entity or a principal within your organization. So lock it to your org ID, that sort of stuff. It's quite key. And there's a limitation that you need to think about. There's 50 aliases and there's 32 KB limit. 32 KB is heaps, but 50 aliases is also heaps. But I would try to use more aliases. If you're trying to use more than 50, then you're probably using the key for a wrong reason. So you might want to split that at some stage. Enable key rotation. This is a key. We've done this within our platforms. You've got an automatic way of enabling your keys, so which preserves your ARN. So ARN is like it gives you a huge string. I'm sure a lot of us know it's a resource name for a particular key, and that stays the same when you're doing an automatic rotation. Automatic rotation does rotate your keys once in 365 days, which is enough. But if you're trying to do it manually, you could still retire the old key and create a new key and make sure you have the same alias and refer the alias across all your usage. So, but the thing is, you get a new ARN when you're rotating your key manually. KMS endpoint, definitely use KMS endpoint. It helps you with how your traffic flows. Control to IAM, so not necessarily all the policy and the controls should be inside key policy. We should also add more controls within the IAM role that's trying to access the key. That's required for things to work. Grants, so the grants is clearly an interesting topic. So you want to make sure that any other principal who's trying to access the key through a different role, if they want to do it, you could give a particular role to basically create a grant on behalf, and that basically works similar to a key policy, but you got to be really careful on who you're giving the grant for and for what time limit. And you want to restrict that if you're doing it in the key policy. You want to just make sure that it is for a AWS resource, and you've got via service restriction in your condition to say it has to be from, say, auto-scaling service. So make sure, it's quite handy to have those grants in check. And always think about auto-scaling, because auto-scaling is slightly different if you're just launching an instance with the EBS backing. It's slightly different when you're launching it through an auto-scaling group or cluster. The step functions. The list of steps that we have to do through step functions is making sure that we share this key, and there's do pre-checks on OUs and which account it belongs to, and then we do a quick wait on whether the KMS key is shared. We've got an SQS decoupled event. It takes like less than a second, but you still have to wait for it because step functions are really fast. So you want to make sure you've got weights and weights in the right level. And then we do the share the AMI and we share the snapshot. And the way we do it is through modify attribute through border 3 we use Python. So, and copy is again an async process, as I previously mentioned. The way we do copy is before we do the copy, then the role that's performing this copy might not have the right policy. So what we do is we also create this policy on the fly and do the copy. And once the copy is done, we check if it's copied. And once all done, then we revoke the permissions at all different levels from the roles, from different accounts, from the key policy. So we basically revoke all of that and also revoke the sharing of the AMI and snapshot, which if we don't do it automatically, then the consumer or the platform, so some person has to do it. So we try to automate all of that. And once that's done, we try to clean up the things that are not needed. For example, we don't want to leave debris. So we try to clean up those things there. And once all of that is done, we make sure that we send a message back whether it's failed or success, which is pretty fundamental really for step functions. And some of the implementations details on how we approach this. This is our second SAM pipeline. So we've done one before. I'm a big fan of serverless framework. I haven't done much of LB SAM. I mean, in production, I've played with it quite a lot. But this was our first productionized SAM pipeline, and it's pretty fast, and it gets you onto your running tours pretty fast. So you could just focus on your delivery rather than your development setup and your deployment of it. And we use Jenkins in the back. We also have a unit test and integration test written, which is a norm really in a lot of enterprises. But this integration test basically says when you're checking into a particular branch, you basically try to create a real run of the product. Basically copy, let's create a temporary AMI. We bake a temporary AMI, we copy it through 2 different accounts, and we make sure it is getting copied securely. And we do all those checks through a separate pipeline. So that was a good one. When we did that, it was quite useful because you could pick up things quite early in the game. The other thing is, if things fail, what do? We've got a Teams operational channel. So we've got a hook. So if things go wrong in our step functions, we raise a catch. We raise an exception. We catch the exception. And we make sure that we know it first before the consumer screen. And this is something we are trying to trial for a lot of our stuff, like say the VPN connections and a few other service catalog products that we are looking at. It has come quite handy. And some of the failures, you would see failures in step function failures are quite clear. And if you want to go in detail, because we are backing our step functions with Lambda, so you can go to the Lambda logs and have a look as well. Some of the metrics to look at is even Bus has metrics and States has metrics, Lambda metrics. So if you bring them all together, you get a really good view of what's happening in this particular use case. And there's a looping behavior that's set inside our state machine, which is basically I think this is slightly tuned now, so it's probably not ideal to discuss it. But what you could do is you could actually set a looping behavior saying, I want to try 10 times, and after the 10th time, I'm done trying. And you can set intervals between those tries. And that's like a validator. Pull create, which is a part of the CFN helper, which has got an inherent 2-minute checkup. Again, that's pretty useful if you're using custom resources that's backed by a Lambda and CloudFormation. We had to focus on our SSM return structure. A shout out to the team. We had a bit of a discussion around how would the consumer know if it's copied or not. And one way is to say, we've got a parameter here, and you could go here and check. And that structure is quite key. KMS request infrastructure was updated to handle multiple accounts, which means that currently we're dealing with EBS, but what we could do is extend that so that it can be done for S3 or RDS or any other key sharing scenarios. We also do OU checks, which show that it only gets shared from it's a one-directional share. It doesn't go beyond what we intended it to do. So there's lots of checks out there to do that, and also kind of double, triple check whether the account is right, and make sure we've also trying to make it extendable to make sure that it can be shared into the right account rather than sharing to any account. It has to be into a group. So we've got account tagging in place now. Our architects are working on account level tagging, which could be really, really useful when you want to limit on who is sharing and where this is getting shared to. Some of the limitations and the constraints, we know that these are the constraints as we looked at. Currently, we only support one EBS that's backing an AMI snapshot. You can extend it to multiple. There is, it's not a limitation really, that's the way the copy works. For a 40 GB snapshot, it takes around 6 minutes to 10 minutes if we're lucky, 6 minutes. But for 100 GB, it's not too far away. It's still like the range of 10 minutes. Again, that kind of varies depending, given a day and time. But yeah, so it takes a little bit longer than you would expect it to. And yeah, that's the polling part. And we've got checks to make sure that it is owned by a source account. It's not a marketplace AMI. You cannot copy a marketplace AMI based on design. A target account cannot be garbage to make sure that they're not trying to share it to some other account outside our enterprise. We've got checks in place for that. And again, this is the one directional flow. We don't really let consumers, or it again depends on what you want to try to do here. We don't want things to be copied from, say, core accounts, say from where our firewalls are running and stuff like that, into a different consumer account. So you kind of have those restrictions in place. Cross-account OU is possible. So if you're copying from non-prod to pre-prod, yeah, but not for prod. So you don't want to bring prod stuff into non-prod. So without a security check. Some of the possible iterations, some of this is already happening, and some of this is a bit of a long shot, really. The easiest thing is to allow it for multiple EBS, although the use case is very much targeted towards a single EBS backed AMI. Not many people would use multiple EBS backing AMI. We can extend it to RDS snapshots. Yeah, definitely. We've got an intention to create a KMS key sharing facility for other services, logs and S3 and for replication and stuff like that. And this, I'm just saying it here, and it's just my own perception, not to use Jenkins, but to use code pipeline. But I think big enterprises do have it's really hard to move from one product to another. But I think BNZ is quite lucky because I've seen the last 2.5 years, 2+ years, there's a lot of agility in the team and the technologies that use, which just makes it a lot fun to work with. And this can be a pattern going forward when using control tower, because we've used a separate pipeline. Normally we bake it into this humongous pipeline that Landing Zone has for all our baseline and our releases. We basically split that out. And the way we deliver new features are going to be separate pipelines rather than putting all of that into the same Landing Zone, which makes it easier when we move to control tower, which is going to happen soon. And we could aim for doing more larger AMIs, and also look at integrating with ServiceNow, which we use, just going beyond just Service Catalog. We could launch these services using ServiceNow, which could be an integration that's to come later. And demo, I had a plan for showing a demo on the console and the code, but I cannot due to different reasons. So I'll leave it there, the demo. And this is just our team. I know our team or the wider cloud platforms actively recruiting, and yeah, so these are the guys who built the AMI transporter and all the other self-service stuff. I can see Scott here, I don't know, but yeah. So that's a PO, Steve. Todd's missing because he's in Auckland. Yeah, so that's us. Thank you.
Cool.
Over to you, Chris.
Cool, thanks, Dan. Hey, I'll just bring Dan and Todd on. Once Todd's ready, I'll bring him on. Thanks, guys. That was super thorough. Now, just for everybody watching, Simon's presentation will only be 10 minutes, so you won't be here until 8 p.m. as well. Very thorough presentation. Now, we had a few questions as well. I'll just find them in the chat. So we had one from Jason. Where was it? Oh, okay. It asked about patching, and so asked about what critical severity patching. Do you have different processes and procedures for, critical patches versus sort of more lower importance patches?
Yep, I can answer that. Officially, there are different guidelines we have within the bank for how quickly patches need to be deployed based on the criticality, with obviously patches that have the highest CVSS scores having to be rolled out within 7 days. Other patches, the less critical, you can have I think it's up to 8 weeks for some patches. We decided in the platform space that was too difficult. It was easy to get into a standard pattern. So what we've adopted is a 7-day patch cycle for everything. We don't care if it's critical or non-critical. It's just a bog standard approach. We publish the patching calendar to all of our consumers so they can lock it in. They know when it occurs. Patching basically starts the second Tuesday of every month. And we have a phase set of schedules. So our non-production accounts by default will get patched the day after the patches come out on the patch Tuesday. So basically overnight on Wednesday. That means Thursday, their accounts are ready for them to do whatever testing they want to do. The following evening, we patch the pre-production. So again, if consumers aren't using the non-production accounts, or they do limited testing there, they can test pre-production the following day, and then we start patching production over the weekend. We do one AZ over the weekend, and then we give them a day to make sure everything's okay on the Monday, and then on Tuesday night we patch the second AZ, and then if their account's using 3 AZs, we patch the other one the following day. So basically within 7 days, the patches are fully deployed. And we do those patches every week, those maintenance windows every week. So if someone stands up a new instance after the first week of patching, it'll get picked up the following week and patched according to whatever environment it's in. So that's just a standard thing we publish. All of our consumers theoretically know about it, and it's up to them to do their testing. So they know which day every month they should do their testing. And we leave it entirely up to them how much testing they choose to do.
Okay, cool. So really conscious of time, so I'll keep this brief. So I'm just going to cut it. We'll go to one more question, I think. So Rom asked about nice to use service catalog. He asked, how do you encourage your consumers to try other products and services, say in their sandbox accounts?
I can quickly answer that one as well. We basically leave it up to the consumers. So if consumers want to provision resources themselves and deal with all of the pain and hassle that goes with making sure they're compliant and having our cybersecurity team go through their application when they're ready to deploy with a fine-tooth comb and pulling them up on all sorts of things that they've got to go back and retrofit. If that's the way that the consumers want to operate, then we let, say, fill your boots, carry on. It's not our issue. And all we can do is basically encourage them by saying, hey, if you want to take all that pain away and you don't want to have to worry about that, you just want to focus on building your application and leave all the nitty-gritty security controls to us as much as possible, then we make this option available for you. This is how you can easily incorporate into your infrastructure as code. It's up to you to give it a try and see if it makes your life easier or not.
Okay, thanks. Okay, awesome. Okay, thanks, Todd and Dan. That was really detailed and really good. So I'll have to probably review it on YouTube as well to try and take that all in. But yeah, there's tons of information there. So thanks heaps. So I'm going to pass over to Simon from Linz. I'll just get Simon up onto the screen, and I'll get Simon's presentation if I can see it.
I hope you can see that now.
No,
that's it.
Oh, picture
that's
in
it.
picture.
Yep.
Okay, cool. Oh, you're Simon.
Okay, so hopefully my slides are up there now. Okay, so yeah, I'm going to keep this under 10 minutes. It might mean moving through some of it quite quick. So I already did a quick introduction. Tōtutu whenua. So I'm tasked with extracting information, topographic data, features for topographic data sets from imagery. And I am leveraging AWS storage and compute to do this, but especially after hearing that last presentation, I'm by no means an expert. More using it to enable sort of desktop workflows. So there's an example of a few of our topographic features there from our open data platform. There's things like building outlines, we have roads and rivers, and vegetation coverage. A lot of these things go onto our actual physical map products. So we've been running a few investigations recently, looking at deep learning, looking if it's ready for us, if we're ready for it, and what sort of results we're getting out of that. So we'll run a recent investigation looking at, for various reasons, we chose buildings to see if we could extract those. But these investigations are by no means limited to buildings. We were interested how we could extract vegetation cover. We put exotic and native and scrub and things like that as contextual data into our map products. So we have a lot of aerial imagery. This is our open data platform, and anybody can get access to that and download that. Within that, those aerial imagery products, there is a lot of detail, but we traditionally extract that with the human eye. And we want to move away from that into the future. So an image comes in, we have our cartographer, and they're traditionally extracting feature by feature. And we can scale that in somewhat of a linear fashion. But we want to take the cartographer's knowledge and couple the machine and the cartographer, and essentially look at these images and extract all the features across multiple feature types. We're sort of within a few minutes per per image, really. So that will allow us to keep up with the temporal elements as more and more imagery comes in. We have a lot of latency right now, but as we're moving towards the future of these ideas of digital twins and representations of the real world, we need to reduce that latency. So we did an investigation looking into tools. We decided to use this open source platform called Rust Division that wraps PyTorch, which is Facebook's AI framework. Using this abstraction of Rust Division allowed us to get up and going really quickly. And so it also provides this pipeline that has all these machine learning steps, deep learning steps for the training and prediction, evaluation, and bundling of those packages. So I was tasked with looking into how we can scale the extraction of these features from imagery. I did not want to go just for an investigation, ask for 10,000 New Zealand dollars for a GPU. And of course, anybody experienced with these deep learning and computer vision problems, we need a GPU. It was a lot more practical to speak to my managers and our AWS team here at Land Information New Zealand to get access to these GPUs that do essentially these $10,000 New Zealand dollar GPUs essentially being leased to us on AWS for $3 if we're paying the full price. But as we can see there, the spot instances, and for those that are not aware of spot instances, it's spare EC2 capacity where we can get discounted pricing outside of high demand times. So we could even pay sort of 90% of that $3 cost. And there's a huge array of benefits. It seems people are pretty up to speed with AWS in this conversation, so they'll be aware of many of those. So we're using batch to I guess, get access to that GPU and to be able to orchestrate our jobs. Again, I won't go into too much detail as I planned about batch because it seems people are very advanced in their knowledge around AWS in this community. So we use CDK to deploy our infrastructure, and it's got all these benefits of being self-documenting and just being easily duplicated infrastructure was great. At a few times we had parallel infrastructure we could deploy with a push of a button and start running parallel machine learning projects. I was going to use some of that self-documenting, as I mentioned, CDK code to talk about the different elements of batch, but I think essentially I'll just leave it as we're using batch as the core AWS component of this. And that's giving us access to that GPU and the orchestration around that. So essentially we end up with something like this, where we have buckets full of all of our imagery that's coming from around the country. And then we have these things, and I wasn't planning to go into much detail of the actual deep learning part of this being AWS talk, but we have labels, and this is the context for what a building is. Essentially, it's a vector outline of labeling the buildings for the training data sets. So by using batch, the great thing is we have access to these environments we deploy that are GPU and CPU. So it means some of these machine learning pipeline stages aren't so intensive on compute, and we can farm them out to these very cheap CPUs and optimize pricing. And then when we're doing the true computer vision stuff, we can send it off to the GPU. Again, so batch via the queues is making available. So we're making available our Docker and Raster Vision software available on Docker. With that, when we use CDK, we deploy to the ECS registry. So I mentioned labels. This is just closely what a label is. We've got that context there that is coupled with the imagery. So once we have this all deployed, we can start training a model. This is a bit of an abstract look at how we train these things. We're using SNETs or convolutional neural networks. And so we have this image. We have, let's say, the triangles of buildings in this case, and we outline those buildings in imagery, and we run through what we call epochs or iterations of training, and we hope as we train, the model gets smarter and smarter. And I won't go into too much detail around the specifics of these neural networks, but then when we want to use that model, hopefully we can filter out with our computer vision what our buildings are. So our real product of this is the bundled deep learning model. And once we have that, we can start applying it to new images, pointing images we have in our S3 bucket. So I'll model at those and letting it loose. And so we started getting, this again was only an investigation. There's a lot more we can do in terms of tuning these models. This was sort of it was actually a 6-week project, and we were seeing some pretty good outputs. We have different resolutions. On the coarser resolutions in the rural areas, you see a raw output. And these aren't perfect at this stage. There is noise in there, but compared to the amount of time we put into this, compared to what a human would put in, the preliminary results are very good. So we also, to remove some of that noise from the raw deep learning predictions, we also apply some building regularization via an algorithm, and you can see the results of that there. It's much more user friendly for our users. So what I was very interested in this, again, it's all about scale. So we had a look at a brand new imagery data set we had come in, and we predicted across the whole Hawke's Bay data sets. And that's 7% of New Zealand. That ran in under 24 hours. But again, so batch has this concept of job arrays, and we could easily do more parallel computing across the images that make up this data set and reduce that time. And the price ends up being about the same because we're using more resources, but we're using them over a lesser period of time. So it really answered our questions about scalability. So again, I wasn't ever planning on going into lots and lots of details of all the services I'm more of a using this for a data science perspective, and this is really a story of enablement. Well, I'm no longer stuck with the power of a laptop. Even when we have these laptops with GPUs, you start the software up and it normally says GPU too small. So this is going to, AWS and the investment that Linz has made in it is really going to enable new ways of working for us, reduce latency and getting products out there, better information, and even the chance to look at more data sets that our users may require. So I do want to say thanks to the Linz AWS team that have supported us in this, and Xavier. So they're the ones that released this Rust Division software that allowed us to get up and running very quickly with these deep learning frameworks. So feel free to get in touch. I'm particularly interested to hear if anybody else in New Zealand's doing computer vision like this with imagery, and what knowledge we could share. So that's the quick version of it.
Okay, cool. Okay, thanks heaps, Simon. It doesn't look like we had any questions in the chat, but you know, it was really good and it was short as well. So I think people were questioned out from the BNZ guys as well. That was really good, man. So we've got the quiz in Kahoot now. We've only got 4 people in there, so first prize is a $50 AWS credit. Second prize is some AWS user group cups, which have a feature of some dye leakage, but you just have to deal with that. And well, third prize is just the glory of getting third as well. So we've got 4 people in there. I'm very conscious of time. I will give people 30 seconds to get in, and then we'll start the quiz. So I'll just see if I can share the screen on that as well while we wait. So, yeah, cool. So, oops. And I'll take Dan off. Oh, sorry, Simon off the screen too. Okay, so we've got 4 people. I'm going to start the quiz now. So if you want to join, then do it really quick. Okay, starting now. First question is just to make sure you can click on the button. So I don't think you can get this one wrong. So if people on the quiz can just choose any of these answers, I'm pretty sure they're all correct. Okay, so obviously a few people didn't answer the quiz, so we'll carry on. Okay, so the next question is a real question. So if you get them right, you get points, and the faster you get them right, you get more points. Okay, cool. Service catalog. So 3 got that right. Okay, next question. Cool. Okay, so there's your points. only one question question answered that time. I think it might have been a bit short of the time frames, but okay, so there's a little error in that quiz because red and blue were the exact same answer of Melbourne and Auckland, but unfortunately we only got one wrong. Right, so for the people who chose red, our apologies, but we're just going to carry forward with that. You were correct, but we got the quiz wrong, so sorry. Well done all. Okay, so it's obviously a hard question because nobody got that one right. And last question. Okay, cool. Everyone got that one right. Okay, so that's all the questions done. So podium. Okay, well done, Graham, and well done, Terence. And as I said, apologies for that question about the new regions. We'll put a note in our backlog to have somebody check the quiz as part of our process, because first time we've done quizzes, so we've made a bit of a mistake. But please forgive us, and if you missed out on cups or credit because of that, my apologies. Cool. So Graham and Terence, please reach out to us on that email address on the AWS user group email address, which is earlier on in the chat, and we'll arrange to get your prize to you as well. So yeah, that's it for today. We've got a few minutes over. My apologies, that was a problem for you as well. I'll be putting into LinkedIn and Meetup some stuff about the December physical meetups at Christchurch and Wellington. As I said before, would really love to get some people to speak. Obviously had Tom on the chat reach out as well for Christchurch. And we'll end it there, and hope you guys have a good evening. Okay, bye-bye from me.